we now take a look at some linear models in word problems. And this linear model that I'm going to show you is quite prevalent in word problems. In this first problem, Alex has a job which has a base salary of $1,000. Now that's a base, and so he's going to be earning that amount no matter what. And then he's receiving a 4% commission on his sales. So they want us to write a linear equation for this. So let's do it this way. Let's say y is going to equal $1,000 that he's going to earn plus 4%, which we can write as a decimal, 0.04, times his sales x. Notice how easy that was to come out. Now we could rearrange this to put it into slope-intercept form, 0.04x plus 1,000 if you wish. Personally, I like the first one better, but this second one is more of a match with how we do things here, at least in America. Quite frequently, we have this pattern of a base price plus a rate that goes beyond it. For example, if you want to mail a package, they charge you by weight. There's a certain price for a base weight, and then they add on so much more per ounce. If you have a cell phone bill, it costs so much per month and then so much per minute beyond that. This is a fairly typical pattern that you want to get used to. Now, to graph this, you know that you're going to have a y-intercept of 1,000. So that's very easy to plot, but the 4% increase, that's a little bit more challenging to write out. What I would do is I would pretend, notice my units are not going by 1, my units are going by 10,000. Let's find out what happens when we go 10,000 and multiply that by 0.04. You're going to get 40,000 up there. And then you're going to have to move the decimal 2 places to the left, which gives you 400. So we know that the point 10,000 comma 400 is going to be on that graph. Well, that's 400 beyond the initial $1,000, so that's 1,400, and we can plot a point right there. And we can see that this graph is rising, and that makes sense because as you have more sales, the salary is going to go up. What is the y-intercept of the graph? Well, we've already stated that the y-intercept is going to be 0, 1,000. And what does that mean? Well, we want in context to describe both a rise, well, not a rise and a run, that would be the slope. We want to describe both the 0 and the 1,000. That 0 refers to no sales. So I'm going to say with no sales, basically, that means that Alex is going to earn 1,000. So I'm going to say Alex's base salary is $1,000. Which is something that was already given to us within the problem, but we wanted to specify that because that's what the directions are asking. Now, what is the slope of the line? Well, that was 0.04. And what does it mean in context? Well, a slope is a rate. So I'm going to say this is his rate of commission. And if you want to try to describe that in terms of a slope with a rise and a run, you can say he earns, for example, he will earn an additional $400 for each $10,000 of sales. Notice how I have both a rise and a run in there. The rise is how much he's going to be earning, and the run refers to the X values here, which is the amount of salary with that increase. How much will he make if his sales for 1 month are $30,000? Well, you are going to take your equation and substitute in 30,000 for X, as I'm doing here. So 0.04 times 30,000, that will be 1,200 plus his 1,000 base salary, and his salary for that month would be $2,200. This next problem takes up a little bit more space, but we need to somehow figure out what's going on here. Please read the problem. I'd like to call attention to the scaling here. Notice how the year starts with 0 representing 1980. This is a fairly common pattern in word problems because you don't want to have x values of 1980, 1985, 1990, etc. It's a lot easier to substitute in values such as 0. Notice that they have labeled this upon the axis and the amount of money going up, or sorry, miles driven going up the side here. And you always want to look at your graph and the scaling before you go any further. And they were extra nice by giving you the equation of the line right here at the very beginning. They've even stated the restriction that x must be greater than or equal to 0. In other words, this model does not work for years before 1980. Now they want us to use the equation to approximate the mileage for the year 2005. Notice that we are going to have to use x is equal to 25 because 2005 is 25 years after 1980. So we are going to substitute that into the given equation, 142 times 25 plus 9,060. And I've already done that ahead of time to find out that the value will be 12,610. And that will be the predicted or approximated average yearly mileage for the car. Now what they want us to do is they want us to use the equation to find an approximation for the year 1985, and that would be when x is going to equal 5 for this problem. So the approximation will be 142 times 5 plus 9,060. And that is going to equal 9,770 miles. Now, compare this with the actual value of 9,700 miles. Basically, we can say this estimate is 70 miles more than the actual mileage. Now, they're asking us what is the slope of the line. Well, that is m is equal to 142. And what does it mean in the context? Well, I need a rise and a run, and the run is referring to the years. So I'm going to say each year, right off the bat, that is going to describe the run. And then I want to talk about the rise. Well, 142 is a positive number. And so I'm going to say we drive our cars approximately 142 miles more than the year before. Notice how this description has both a rise and a run built into it. Now, what is the y-intercept? Well, that is going to be 0, 9,060. And they want us to interpret it. Well, the 0 represents the year 1980. So I'm going to say in 1980, the average car was driven approximately 9,060 miles.